Good morning, MVGR. Today we will have a very brief discussion about what is a C program. We'll start with a very simple C program and what is the structure of a C program, and then what is a variable, what is the data type of a variable, how to access or how to print a particular variable, and how the variable memory is allocated and how the values are stored in the memory, which is RAM. So without much delay, let's dive into the program. This is a very simple C program. This has a few steps. If you look at this, the first statement is hash include stdio.h, which simply means include the standard input output header file. .h means is a header file which has the source code for printing this text, which is given in the printf function, which is part of the stdio.h. So some functions can be accessed which are included in the header file without the need to write the code for implementing that. And then we have the main function, which is the starting point of the program, and the main function can be a void main which does not return anything to the operating system, or it could be an int main which returns 0 once the program successfully gets executed. So main is the starting point, and between the hash include stdio.h, which is also known as the preprocessor directives, there can be some global variables which are accessible across the file, but here, to start with a simple program, we'll not go into the global variables. So this is int main, and then there's a curly brace, there's a closing curly brace. This is the opening curly brace, this is the closing curly brace. This is the block of code that is part of the main function. So within this we have a variable called Rakesh, which is of integer data type. So when we say int Rakesh, something like this, it will simply allocate the memory for a variable named Rakesh, and then we can assign a value. And then through a formatted printing option, we can print the value stored in the Rakesh using the format specifier appropriate for the data type given for that particular variable. So here, when you say int Rakesh, what is the memory size of integer data type, that much memory will be allocated, and that memory can be accessed using the variable name or identifier name called Rakesh. And when you say Rakesh equals to 15, the value of 15 will be stored to that memory. So once you use the printf function, printf value in Rakesh equals to percentage d Rakesh, whatever value is stored in the Rakesh memory or memory uh, identified by Rakesh will be printed in this. This is called format specifier. Now let us go slightly. Once the main function executes whatever statements are there within that, after the declarations, this is declaration for the variables which allocate memory for the variables, and then you do some expressions, some calculations, and then some input output operations. Once everything is done, all the statements are executed, you will return, and then the program will end. So this is the basic structure of a C program, the preprocessor directives. If there are any global variables, so global variable declarations will be there, and then the main function, which is the starting point of the program, and then the variable declaration within the main, and then some statements and a return statement. This is the simple structure of a C program. Now let us look at how the value is stored inside the memory. This is a simple representation. Assume the entire white screen as the RAM. Within that, a small memory chunk is allocated, and that is identified by the variable name or the identifier name called Rakesh, and the value of 15 is stored. But if you know a little bit of computers, you will understand that computers cannot store or understand the digital numbers like this, decimal numbers. All that computer understands is binary numbers, which are zeros and ones. So everything that is given in decimal will be converted to zeros and ones, and then it will be stored. How it is done, we'll see in a moment. So now let us look at how a variable declaration is done and how the memory is allocated. So int age equals to 15. So the int is called data type, and the value assigned is 50, and the variable name is age. So within the RAM, some memory is allocated for that depending on the type of the data type, or type of the data, to simply call it. Integer takes 4 bytes, so 4 bytes of memory will be allocated. How it is done, we'll have a look at this. So here is the memory map or memory representation. Int A is the declaration statement which assigns the memory of 4 bytes starting from 2032 to 2006. 203, 4, 5, 6. 4 bytes of memory is allocated. So within this, the data of A equals to 12 is assigned. So 12 of base 10 is converted to binary numbers, which comes out to be 1100. So that number is stored. And how that is stored? The 4 bytes, byte 1, 2, 3, 4, in the least significant bit, you have the data, and then as you go towards the more significant digits, as the number is very small, the rest of this is zeros. So you have only 1100. So if you look at from the right side, it is 0011. That is the data, and the remaining thing, everything on the left, you call it as zeros as of now. So once the value stored is higher, then the zeros will turn to, when the more number of digits in binary come into existence based on the larger decimal value, more number of digits will become ones. So here the 4 bytes of memory, which is typically assigned for an integer variable in most of the modern compilers. Earlier days, the compilers used to assign only 2 bytes for the integer data type, but most of the modern compilers will assign 4 bytes. So this is how the value of 12 is stored inside the memory, which is 4 bytes for the integer data type, and 4 bytes, each byte is 8 bits. 1 byte is equals to 8 bits. So 4 into 8, total 32 bits of data. Whether you use other things or not, maybe you are storing a very small value like 12, or you may be using a very large value like 65,000 or 70,000 value, depending on the requirement. So this is an example of an integer data type. Integer data type has only the exponent, There is no mantissa, there is no fraction component of it. Now similarly, let us have a look at the floating point data type. Floating point data type has something to the right of the decimal. This is 0.1011 in binary. So when you convert that into a decimal number, it turns out to be 0.6875. If you can look at the bottom right corner, how the binary representation can be converted to decimal and how the decimal number system can be converted to binary. We'll discuss that in a different session. So as of now, if this is the binary representation, 0.1011, that is equivalent to 0.6875 in decimal number system. So before that, a floating point data type also has 4 bytes of memory, which is 32 bits. However, all the 32 bits are not used to store the data, the exponent component of the data only, because here you have the exponent and then you have the mantissa also. After the decimal, that is mantissa portion, and before the decimal, that is the exponent portion. So for the exponent portion, 8 bits is allocated, and for the mantissa portion, 23 bits are allocated for a floating point data type, and then 1 bit will be for the sign, whether it is a positive number or a negative number. Similarly, for an integer also, the most significant bit or the highest bit to the leftmost one, that 1 bit will be used for sign, whether it's a positive integer or negative integer, the value, and then remaining 31 bits will be used for storing the data. So this is the exponent component, which is the integer component of the floating point data type, and the mantissa, which is the decimal point of the data. So if you look at this, this is a very simple example. A decimal number 123.456, and how it can be represented using the base 10. So 3 is in units place, so 3 into 10 power 0, and 2 is in ones place, so 2 into 10 power 1, and then 1 is in hundreds place, so 1 into 10 power 2. Similarly, as you progress from here to here, this will be 1 by 10 power 1, 1 by 10 power 2, 1 by 10 power 3, which is 0 0.1, 0 0.2, 0 0.3. So 0.1 into 4 plus 0.01 into 5 plus 0.001 into 6. On similar lines, the data as it is represented in the memory, that is in binary format. So let us look at what this mean when it is converted to a decimal number. So this is 1010.11. This is the binary number, not the decimal number. So this portion is the mantissa. So here it is 2 power 0, 2 power 1, 0 into 2 power 0 plus 1 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3. So 2 power 3 into 1 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0. So this constitutes 2 plus 8, 10, that which is the integer portion or the exponent portion, and then the mantissa portion is 1 into 10 power 2 power minus 1 plus 1 into 2 power minus 2. So 1 by 2 plus 1 by 4, which is 0.5 plus 0.25, which is 0.75. So this is 10.75. If you convert the binary number into a decimal number. Similarly, if you look at the double data type, which is double floating point, uh, because it has the double the size of a floating point, and it still can store the data in similar style, similar type of data, but with a larger data you can use. So this is 64 bits, which is 8 bytes. Out of the 64 bits, 11 bits will be used for exponent and 52 bits will be used for the fraction or mantissa, and sign bit will be only one as usual. So before we dive slightly deeper into that, let us have the basic data types. There are varieties of data types that we will discuss throughout the C programming sessions. However, the basic data types are integer, floating point, double, and then char, which is used for storing a character like A, B, C, D, all these things, special characters like asterisk, plus, minus, divided by, hash, at the rate, exclamation mark, all these things are characters. And then boolean, which stores only 0 or 1. It will be only one bit of data, so it will store either 1 or 0. So you need not use an integer data type which requires 32 bits. Instead, you can use 1 bit data type also to store a very small amount of data, which stores data something like yes or no, married, unmarried, left, right, only two options, when only two options are there, right, wrong, this kind of thing. And then you have void. When you do not know the type of data, you can use it as void. Void means no specific data type is assigned. So let us have a very brief look at the basic data types before we close the session for today. These are the basic data types. One is int, which stores the integer numbers like 10, 5, minus 5, 15, 100, 200, 200, 1. All these things are integers. And then floating point data type, which stores values like 3.14, which is a value of pi generally used, or minus 0.99. All these things are floating point data types. This is double precision floating point, double. So for that, it can still store these values, and it can store larger values also, because it has 11 bits for exponent and 52 bits for the mantissa. Am I right? This is 52 bits for the mantissa. When you compare it with floating point data type, this is only 8 bits and 23 bits. So this can store a smaller value, and this will store a much bigger value. Similarly, you have the character data type, which can store a single character like A included in single quotes or B included in single quotes. Why we should include a character value in single quotes is the compiler may assume that it is a variable name if you don't include it in single quotes. For example, in the previous case here, you have declared int A. Here, because A is not in single quotes, it will consider this as a variable name. If you don't include it in single quotes, it is assumed as a variable name. But for example, if you want to declare a variable something like uh, char, variable name is A, and you want to store value of Z in that. So here A is the name of the variable and Z is the value stored in that variable. So because you are including that in single quotes, it becomes the value. But there could be a question, because the computers understand only zeros and ones, how can it store Z, which is text? So for that, we have something called as ASCII, ASCII values. This is a standard set of values which have a standard number 1 to 1 to 127, or sometimes 1 to 255, depending on what type of ASCII set we are using. So let us have the basic look from 0 to we have 127. Let me open this in a separate tab so that we can look at with a maximum size, slightly bigger one. Yeah. So if you look at the number 65 here, I hope you can see the mouse pointer here. This corresponds to capital A character. So from 65 to you have up to 90. These are the 26 capital letters. Similarly, you have from 97, which is a lowercase a, and up to 122, which corresponds to lowercase z. Similarly, if you want to store the character 0 or character 1 or plus minus, you have the corresponding ASCII values. So those ASCII values will be stored in the form of binary numbers, and each character data type is only 1 byte. Because it is only 1 byte, you can store only a small value, and that small value is 127, the positive number, and minus 128 on the negative side. If you store everything on the positive side, no need to use the sign bit, which you have already seen for the floating point and integer data types. If you don't use that sign bit, you can call it as an unsigned character, and when you say it as unsigned character, you can use all the 8 bits. So you can store up to 255 characters, 0 to 255. If it is a signed character, then you have to use 1 bit for the sign field. So you have only 127 on the positive side and 128 on the negative side. That much you can store. So we have seen a basic program here. So let me conclude by stating the structure of the simple C program again. This is the preprocessor directives, which include the header files, and then if there are any global declarations, those can be given here. Global declarations, global variables, which can be used across the file, across the functions. And then you have the main, you can call it as int main. Then you have to include a return 0 statement. If it is a void main, there is no need of writing a return 0 statement. So this is the main function, which is the starting point of the program, and then you have the declaration of variables which you want to use, which will store the values, and those values you can access using the identifier name or variable name. And then you have some statements like input output statements or expression evaluation statements, which will be executed, and then this block of code is executed. Once this is done, the function will be exited. Once the function exits the main, the program closes. So let me run this once. So the value in Rakesh equals to 15. So this is the string that we have given, value in Rakesh equals to, and percentage %d is the format specifier, and Rakesh is the identifier name. So whatever value is stored in the Rakesh will be printed here. But if you want to look at what is the location at which this value is stored, then we have to look for the address of that also, because when a block of memory is allocated, it will have a particular location within the RAM, within the memory map of the RAM. Within that, where exactly this is located, based on that address, we can access the variable. That in detail we will see in the next class. So with this I will conclude the session. Have a beautiful day. Bye bye.